Next factoring is difference of squares. So we're looking at perfect squares, obviously, hence the name. We should be aware of our perfect squares that are 1 through 15. Listed them there, 1, 4, 9, is 1 squared, 2 squared, 3 squared, down the line to 15 squared. We should be familiar with those. Difference of squares only happens when there's two terms, and subtraction. On top of all that, they need to be perfect squares as well that you're dealing with, hence the name again. The model here, you have your first term being squared, your second term being squared, you have subtraction. You split this up into two parentheses. In there, you basically are just taking the square root of each one. Square root of a squared is just a. You put that in each slot. Same thing with the b's. One's a plus, one's a minus, and it's done. All right. Let's check out a couple. First two, pretty basic, hopefully. X squared minus 4. First thing I'm going to do is open up two sets of parentheses. All right. So they're all ready for two sets of binomials. What we're thinking about, what we're not writing though, what we're thinking about is take the square root of x squared. What is it? Well, it's x. That goes in the first spot here. Then we think to ourselves, what's the square root of 4? 2. That goes in the second spot in each one. After that, you put a plus in one, minus in the other. And the problem's done already. All right, that's it. Same deal with the second one. Open up two sets of parentheses, just set it up. You're thinking about taking the square root of the first term. This time we have a number out front. It's 25 with the x squared. Square root of 25 is 5. Square root of x squared is x, so 5x goes in each spot, in each first spot. Same deal with 49. Square root of 49 is 7. So it's 7 and 7. One's a minus, one's a plus. Doesn't matter what's in each parentheses. So we have that. Next two, last two on this slide. What about these ones? Both of these, 2 and 18, are not perfect squares. 12 and 3 are not perfect squares. But like the first video, we have a greatest common factor. We take out a greatest common factor, in this case it's 2. We look at what's left over. We realize what's inside is perfect squares. So we keep going. You rewrite the GCF, open up two sets of parentheses, and repeat the process that we just did in the problems above. X and X, 3 and 3 for 9. One's a plus, one's a minus. Done. Do not forget to write that GCF out front. Same deal with number 8 here. We have two terms. We don't have subtraction in the middle, but wait on that. We also don't have perfect squares. Again, wait on that. We do have a GCF, just like the last problem we did. What's the GCF between 12 and 3? Well, it's 3. But here's the thing. I told you guys in the first video, always take out the negative. So I'm going to take out a negative 3. I'm going to rewrite what's left over. It becomes 4x squared. And then this becomes a minus 1. 4 and 1 are both perfect squares. We rewrite the negative 3, the common term. Square root of 4x squared is 2x. Square root of 1 is just 1. One's a plus, one's a minus. And there's our answer.